Hello, students. And first, I want to remind you that we are on our map schedule today and tomorrow. So for October 19th, this is the lesson for second period. And for October 20th, this is the lesson for, I should read, fifth period algebra. So be mindful that you won't have algebra on both days. So let's think what we're going to talk about. We have a do now where we probably already have had a discussion about the difference between surviving an event and thriving in the world. We will learn today how to solve absolute value equations. Our essential question is, how can I solve equations that have an absolute value term in them? We remember absolute value is the term that is within absolute value bars. It looks sort of like football goalposts, some people say. Our assignment will be to watch the video and complete the problems. We're going to work on problems 9 to 18 in your notes where it says, what if there is stuff outside the absolute value bars? And on 9 to 16 of the homework pages, we're going to try to get a few of those done as well. I want you to be sure to explain your thinking for problems 17 and 18 that we get to. Our exit ticket, you'll see we're going to complete a statement and rewrite the statement on absolute value equations. For homework, we're going to do number 1 to 8 of homework 5. We hopefully will get to 9 through 16 during this lesson. And on our Unit 2 assessment, I want you to complete number 13. We have a virtual open house on Wednesday from 12 to 3 and 5:30 to 7. Important notes, please keep your interactive notebook up to date. At this point, we have completed 5 pages. Don't forget to look for and complete your Wednesday assignment each day. That counts toward attendance as well as a grade. And don't forget to frequently check your grades in PowerSchool. And you need to meet with me biweekly at least to show me what you are doing in your notebook. Remember, we're doing our do now work and our exit ticket is in teams. We're using our physical notes for homework and for our class problems. So please don't let your work go till the weekend. It will be scary if you don't keep up with everything every night. You need to practice algebra every day. So our do now question, why is it important to go from surviving an event to thriving in the real world? What's the difference between surviving and thriving? Which is the one that is more preferable? And we'll talk about that in class. And I'd like you to spend a minute or two responding to that prompt. Our exit today, we will complete this sentence. An absolute value term when blank can never be blank because it represents blank from blank. So we're going to complete that sentence when we finish our lesson. So we're going to start with our absolute value equations. And I want you to take some notes today. So make sure you open your notebook for this. So let's title this absolute value equations. And steps to solve. Step 1, make sure the absolute value expression is isolated. Isolated meaning all by itself on one side of the equal or inequality sign. You could have an absolute value inequality. Okay, set the inside, the part inside the bars. Okay, so we could have 5x minus 2, but that's inside absolute value bars. So you need to set what is inside those bars. equal to both the positive and negative number from the other side of the equation. And the reason that is because absolute value represents distance from zero on the number line. Okay, step 3, solve both equations. Step 4, write your answer as a solution set. And that will be x equals, we will use brackets, a number, comma, another number, close the bracket. That is how we represent our answer when we do absolute value equations. And we want to remember to show our work when we do these. So let's start with the first couple of problems. Some examples. Okay, number 1. We'll begin with x. The absolute value of x equals 2. So we will say, what is the absolute value of x? The absolute value of x equals x. So we will set x equal to 2, and we'll set x equal to negative 2. So our answer, these are both final answers, x equals the set of all numbers such that x is equal to negative 2 and 2. And that's the form of your answer. Let's do another one. Let's say the absolute value of m equals 14. So we know that the absolute value of m is m. So we will have m equals 14 and m equals negative 14 because both of those are 14 units from 0. So our final answer represented as a set is negative 14, 14. Number 3, let's change our color. And let's say 5z, the absolute value of 5z equals 40. Now remember, step 1, isolate the absolute value term. Is the absolute value term isolated? Yes, it is. Now we're going to set it equal to both the positive and negative 40. So here's our 5z. The absolute value of 5z equals 5z. So we'll set that equal to the positive and negative 40. 5z equals 40 and 5z equals negative 40. So let's solve the equation on the left first. We will divide both sides by 5. And z equals 8. I didn't do such a good job. Let me rewrite that so it's easier. Z equals 8. And z equals negative 8. As a solution set, z equals the set of all numbers such that z equals negative 8 and 8. Our next example, fourth example, the absolute value of negative 7a equals 28. So the absolute value of negative 7a is negative 7a. So we'll set that equal to positive and negative 28. Negative 7a equals 28, and negative 7a equals negative 28. Now we'll divide both sides by negative 7. And on the left equation, a equals negative 4. On the right equation, a equals positive 4. So our answer is a equals the set of all numbers such that a equals 4 or negative 4. Okay, let's go through to a few more examples. Let's work with that's a little more complex terms. So we'll do d plus 1 equals 8. So the absolute value of d plus 1 is d plus 1. So we'll set that equal to 8 and negative 8. Subtract 1 from both sides of the equation. D equals 7. And on the right side equation, D equals, I accidentally wrote my answer instead of the 1. Okay, D equals negative 9. Here's our answer set. D equals the set of all numbers such that D equals negative 9 or 7. And that's a full answer. Our next example will have w minus 3. Make sure you show your work when you do these. It helps you to solve them better. So the absolute value of w minus 3 is w minus 3. So we'll set w minus 3 equals 4. W minus 3 equals negative 4. We will add 3 to both sides of the equation on the left. W equals 7. We'll add 3 to both sides of the equation on the right. And W equals negative 1. So W equals negative 1, 7. And that's our final answer. Let's do a couple more examples before we get to your notes. How about d plus 1? We do 4n plus 2. Make them a little more complex. absolute value of 4n plus 2, and we'll set that equal to 34. So the absolute value of 4n plus 2 is 4n plus 2, which we will set equal to 34 and negative 34. Remember, we isolate the absolute value term, then we can remove those absolute value bars and set it equal to the positive and the negative. So let's subtract 2 from both sides. 4n equals 32. Divide both sides by 4. And n equals 8. And on the right-hand equation, we'll subtract 2 from both sides. 4n equals negative 36. When we divide by 4, n equals negative 9. So n is equal to the set of all numbers such that n equals negative 9 or 8. And let's do one more before we go to your notes. Negative 2v, be careful, minus 5 equals 17. So we'll set this is already isolated, so we'll set it equal to positive and negative 17. There's our negative 17. So we'll add 5 to both sides of the equation on the left. Negative 2v equals 22. We'll divide by negative 2. And on the right-hand equation, v equals negative 11. On the left-hand equation, we'll add 5 to both sides. Negative 2v equals negative 12. We'll divide both sides by negative 2, and v equals 6. And here's our answer set, negative 11 and 6. So let's go to your notes. And now we have a different sort of problems. We have what if there is stuff outside the absolute value bars? Well, the key is to isolate the absolute value. That's it. And we use the algebra tools, the properties of equality that we've been using. With number 9, we have this absolute value of c, so we need to isolate it from this positive 2, so we will subtract 2. And then we have the absolute value of c equals 10. Then we keep going as usual. C equals 10, c equals negative 10. So our final answer set, c equals the set of all numbers such that c equals negative 10 and 10. And that's the final answer. For number 10, we will add 8 to both sides. And we'll have the absolute value of y equals negative 3. Equals positive 3. So we'll set y equal to 3 and y equal to negative 3. So here's our answer. Our answer set includes negative 3 and 3. Now, important to note with absolute value, do not distribute over absolute value bars. Okay, it's not a grouping symbol for the purposes of the distributive property. So what we have in number 11 is the absolute value of x is being multiplied by 6. So the opposite of multiplication is division. It's the inverse operation. So we'll divide both sides by 6, and then we will have the absolute value of x equals 4. We'll set our two equations, x equals 4, x equals negative 4. So our final answer, the absolute value of x equals all the set of numbers that includes negative 4 and 4. Same with number 12. We will divide both sides of the equation by negative 2 so that we can isolate the absolute value term, which is z plus 3, which was now going to be equal to 7. So then we will have, this is the whole absolute value term. We have to set the whole term equal to 7 and negative 7. Z plus 3 equals 7. Z plus 3 equals negative 7. Subtract 3 from both sides of the equation. Z equals 4. Again, the left-hand equation will subtract 3 from both sides, or z equals negative 10. So our final answer is the set negative 10, 4. Let's look, what about number 13, where we have the absolute value being multiplied by, being divided by a 6. I'm going to make this page a little bit bigger so that I have a little more room to work. I think we're going to need it now. So the inverse operation to dividing by 6 is multiplying by 6. Whatever we do to one side of the equation, we do to the other. So now we have the absolute value of 2w minus 4 equals 18. So our absolute value term is isolated. Now we can set that equal to positive and negative 18. So 2w minus 4 equals 18. 2w minus 4 equals negative 18. So we'll add 4 to both sides of this equation. 2w equals 22. We'll divide both sides by 2. And w equals 11. On this side, we'll add 4 to both sides of the equation. 2w equals negative 14. Squeeze my negative sign in there. We divide both sides by 2. And w equals negative 7. So our final answer, w equals negative 7 and 11. And that's our final answer. Number 14, the absolute value expression is being multiplied. See if I can make this a little bit bigger. Oh, that's pretty big. Should give us enough room. Okay, so the absolute value expression is being multiplied by negative 10, so we will divide by negative 10, and we will add 3. Let's add the 3 first. I think that's much easier for our purposes. So we'll add 3 to both sides. Negative 10 times the absolute value of h plus 5 equals negative 80, excuse me. Now we'll divide both sides. I'm going to change the color so we can show all the steps. We'll divide both sides by negative 10. And now we have the absolute value of h plus 5 equals negative divided by negative is a positive. Now we do finally have our absolute value term isolated. Now we can set it equal to 8 and negative 8. So we will have h plus 5 equals 8, and h plus 5 equals negative 8. I need to darken the color a little bit. Let's subtract 5 from both sides. H equals 3. Subtract 5 from both sides. On this equation, remember, we're doing 2 problems for every single problem. Negative 13. So H is equal to negative 13 or 3. If we made these substitutions and put these numbers back in, we would have a true statement. Okay, go get the eraser and erase some of this. Sorry about that, students, but I want to make room to write our next problem. Okay, so we have 7 times the absolute value of 4n plus 8 minus 6 equals 106. We do not distribute over absolute value bars, okay? So the first thing we'll do is add 6 to both sides. So 7 times the quantity of 4n minus 8 equals 112. Now we're going to divide both sides by 7 so that we can isolate that absolute value term, which gives us 4n minus 8 equals 112 divided by 7 is 16. And that's still absolute value. Now, remember, step 1, isolate the absolute value term. That's what we've done. Step 1 is complete. Now we set it equal to positive 16 and negative 16. 4n minus 8 equals 16. 4n minus 8 equals negative 16. Add 8 to both sides. 4n equals 16 plus 8, 24. Divide by 4. N equals 6. And add 8 to both sides. This should be 4n. I just want to erase that absolute value bar. There we go. It's part of my absolute value bar that I left from the problem above. You know, I just realized I have a plus sign here. Let's do this problem over. Sorry about that, folks. That was just a little mistake on my part. Actually, it gave you a lot of extra practice. I'll have to learn a quicker way to do these erasures or just make fewer mistakes. So let's start that over. Sorry about that. Okay, again, we want to add 6 to both sides. 7 times the absolute value of 4n plus 8, this is where I made my mistake, equals 112. Now we'll divide both sides by 7. 4n plus 8 equals 112 divided by 7 is 16. And that's still absolute value. Now I'll do my rewrites. 4n plus 8 equals 16. 4n plus 8 equals negative 16. Okay, subtract 8 from both sides. 4n equals 8. Divide both sides by 4. N equals 2. Much easier problem. Subtract 8 from both sides. 4n equals negative 24. Divide both sides by 4. N equals negative 6. And that means that n equals the set that includes negative 6 and 2. And number 16, we have a fraction. We're not afraid of fractions. First thing we want to do is add 24 to both sides of the equation. Three halves times the absolute value of 4r minus 4. Remember, we do not distribute over absolute value, equals negative 21 plus 24 equals 3. Now we need to divide both sides by 3 halves. So when we divide by 3 over 2, let's think of what we're actually doing. It's the same as multiplying by the inverse, which is 2/3. So let me show you a little bit of an easier way to do it. So dividing by 3 halves is the same as multiplying by 2/3. Whatever I do to one side of the equation, I do to the other. So this completely cancels. And we are left with the absolute value of 4r minus 4 equals 3 times 2/3. And 3 times 2/3 equals 2. See how simple? Now we've isolated our absolute value term. So now we can go ahead and set it equal to positive and negative 2. Let's add 4 to both sides. And we'll divide both sides by 4. And our answer will be a fraction. R equals 6/4, which we can reduce to 3 over 2. And I told you in algebra we often leave improper fractions. On the other side equation, we will again add 4 to both sides. 4r equals 2. Divide both sides by 4, and r equals 2/4, which simplifies to 1/2. Our final answer, r equals the set of, we have 2 positive numbers this time. Let's put the smaller number first. 1/2, 3 halves. That's the set of numbers that makes up the answer. Okay, so number 17, x, the absolute value of x equals -6. Cannot be, no solution. Let's look at number 18. If we divide both sides by -3, let's see what happens. We end up with the absolute value of 2x plus 1 equals -7. Again, no solution because absolute value cannot equal a negative number once isolated. Okay, let's do a few of these more challenging problems. Let's finish up these. So we're going to divide by -3. Whatever we do to one side, we do to the other, right? So we have the absolute value of P equals -4. Absolute value cannot be negative. Number 10, subtract 2 from both sides. The absolute value of M equals 9. So we have M equals 9 and M equals -9. They're already isolated and solved for us. So the solution set is -9, 9. Let's look at number 11. In this case, we will multiply both sides by 2. Whatever we do to the one side, we do to the other. And we will have our absolute value term isolated. And then we need to solve both of these. So we'll have 4x minus 12 equals 16. 4x minus 12 equals -16. Add 12 to both sides. 4x equals 28. Divide by 4. X equals 7. Add 12 to both sides on the right-hand side equation. For x will equal -4. We divide by 4, and x equals -1. So x equals -1, 7. Now, you might be saying, well, absolute value can't be negative. At this point, this is not absolute value. This is absolute value. This is what cannot be negative. And it's not, so we're okay with that problem. Let's do this problem number 12. First, we'll add 16 to both sides. And we have the absolute value of 3b. Let's make that look more like a b. 3b plus 9. The absolute value of that equals -36. And this is where we have no solution. Absolute value cannot be negative. Problem number 13, the first thing we want to do is multiply by the reciprocal of 4/3, which is 3/4. Whatever we do to one side, we do to the other. And this will cancel. Oops, let's get my problem back. This will cancel, and I have the absolute value of 3w minus 6 equals, now let's do a sidebar, 16/1 times 3/4. We can simplify that, which equals 12. So now we have our absolute value term isolated. 3w minus 6 equals 12, and 3w minus 6 equals negative 12. Add 6 to both sides. 3w equals 18. Divide both sides by 3, and w equals 6. On the right-hand side equation, we add 6 to both sides. 3w equals negative 6. That's okay. Divide both sides by 3, and w equals negative 2. So our answer is the set of negative 2, 6. Let's look at number 14. First thing I want to do is divide both sides by negative 5. Whatever I do to one side, I do to the other. And I have the absolute value of 6a plus 21 equals 3. Negative divided by negative is a positive. So that's okay. So I've got 6a plus 21 equals 3, and 6a plus 21 equals negative 3. Subtract 21 from both sides. 6a equals negative 18. Divide both sides by 6, and a equals negative 3. On our right-hand side equation, we'll subtract 21 from both sides. 6a equals negative 24. We'll divide both sides by 6. A equals negative 4. So our solution set is negative 4. We can have two negative numbers. That's okay. As long as absolute value, once isolated, is not negative, we're fine. And looks like our last two problems of the day. Let's add 3 to both sides of the equation. Whatever we do to one side, we do to the other. So we have 4 times the absolute value of v minus 2 equals 28. Let's change our color and divide both sides by 4. So now we have absolute value is isolated. 28 divided by 4, sorry about that, is 7. So now we have absolute value isolated. It's not negative, so we're okay to continue. We have v minus 2 equals 7, or v minus 2 equals negative 7. We'll add 2 to both sides of the equation, and v equals 9. Over here on the right equation, we will add 2 to both sides, and v equals negative 5. So our solution set is negative 5, 9. Last problem, what will we do first? Little bit tricky. What you need to remember is this is an invisible positive sign. So we have 3 being added to negative 1/2. Think of this as one term times the absolute value of r plus 9 equals negative 11. Let's subtract 3 from both sides. So now we have negative 1/2 times the absolute value of r plus 9 equals negative 14. Now, we have a 1 in the numerator, and we have a 2 in the denominator. That means we can multiply both sides by negative 2, and that will completely eliminate this fraction and leave us with the absolute value of r plus 9 equals positive 28. So let's set r plus 9 equal to 28, and we'll set r plus 9 equal to negative 28. So let's subtract 9 from both sides of the left-hand equation, and r equals 19. And let's subtract 9 from both sides of the right-hand equation, and r equals negative 37. So r equals the set of numbers that are negative 37, 9, and that's a final answer. So you get good at absolute value when you do a lot of practice. So let's go back to our exit ticket. I think I need to reduce this a little bit. And maybe I made it too small. Let's go back to our exit ticket. Yeah, make it a little bit bigger. Okay, so an absolute value term when isolated, let's get a darker color. When isolated, can never be negative because it represents distance from 0. And I'd like you to write that 2 more times. So I think today we've deserved a lot of stars for our hard work. So let's put those stars all over everything we do. You've worked hard. Keep up the practice, and as you do that, you'll be great.